Okay, so we're going to start with vocabulary because I know that's your favorite. Perpendicular lines are lines that intersect and form 90-degree angles. So you have two lines intersecting, right angle. The slope of one is the negative reciprocal of the other. Okay, so what that means is the slope of the first, if that one was, say, 3, then the slope of the second would be negative 1/3. So opposite and upside down. That's what negative reciprocal means. Okay. A perpendicular bisector is a line, a segment, a ray, or a plane. It can be any one of those four that is perpendicular to a segment and bisects it. So if I have some segment here and I have a line that comes through that's perpendicular, then this length will be the same as this length. Cuts it in half. Okay. And then we have theorems. Through any point on the line, there's exactly one line perpendicular to that line. So if I have a line and I pick a point, say here, there's only going to be one line that can go through that point and be at a 90-degree angle. Any other line, I mean, you might have like an 89.9 or a 90.1, but there's only going to be one 90-degree angle, perpendicular line, so right here. And then we have, if two lines are perpendicular, they form congruent adjacent angles. If I'm perpendicular, then this is 90. And this is also 90, and this is also 90, and this is also 90. Because straight lines are 180, so if one of them is 90, then the other is 90. So you get congruent adjacent angles. So angles that are right next to each other that are congruent. And if you have congruent adjacent angles, then you have to be perpendicular. If two lines are forming congruent adjacent angles, so I have a 90 and a 90, then they're perpendicular, because there's no way I can have two lines form angles and get two angles that are congruent but that aren't 90. Because again, a line makes 180, so divide that by 2, you get 90. And then only one perpendicular can be drawn from any point to a line. So if I have some line and then I have some point somewhere out in space, it's kind of the same thing as number 6. There's only one line that can go through that point that will be perpendicular to my line. Any other line wouldn't be perfectly perpendicular. It could be like 89 point repeating 9s, but it still would not be 90 degrees. So I have this example. Remember, this means 90 degrees. In case you forget. Oops, I hit the wrong arrow, sorry. Okay, so when angles in a linear pair are congruent, then the angles are right angles. This angle is the same as this angle, 90 degrees, 90 degrees. So if you have a linear pair, you have right angles if you have two congruent angles. So AC is perpendicular to BD. This symbol right here means perpendicular. Kind of like an upside down capital T, but it's actually two perpendicular lines. So you don't ever have to write out the word perpendicular. You can just make that symbol, and every person that knows math will know what you're talking about. Okay. So if AD is the same as DC, so if we have this length is the same as this length, then this is also a bisector, and that makes it a perpendicular bisector. Good? Questions? All right, so we can use all those facts to solve different problems. So we're going to find the measure of angle x. This is 90 degrees, which tells me that this over here is also 90 degrees, which means that this angle plus this angle add up to 90 degrees. So I take 90 minus 37, and I I get 53 degrees, and that is x. So far okay? I'll erase that later. Okay, now in this one, they don't label which ones are 90 degrees, but they tell us 90-degree lines. So JN, that's this line down here, is perpendicular to OL. That's this part right here. So these are perpendicular together. And then they tell us that OK is perpendicular to OM. So these are also perpendicular together. And finally, because this was perpendicular, then this is also perpendicular. So you have 3 different 90-degree angles happening here. The one on the left and the right, and then the one in the middle. Well, we're finding the values of x. These 2 angles together make 90 degrees. So this plus this equals 90. So we're going to have to put those together. So I have 5x minus 13 plus 3x plus 7 equals 90. 5x and 3x is 8x. Negative 13 plus 7 is negative 6. Add 6 to both sides, and you get 8x equals 96. And then divide by 8 to get x is 12. Okay, let's work some out. Ignore D. We're not doing the proofs on this one. So here we have a right angle A. So this is also going to be a right angle, which means x and 34 together are going to add up to 90. So to find out what x equals, I do 90 minus 34, which is 56. Okay. Here, 90 degrees, so these 2 are 90 degrees, and I have a 4x plus x. So 4x plus x equals 90, which means that 5x equals 90, which means that x equals 18. Yeah, 18. Any questions on that? Okay, here we get a little bit confusing because they throw this 52 in here for no good reason whatsoever. If this is 90, this is 90, which means that x equals 90. The 52 is thrown in to confuse you and make sure you're paying attention. So make sure you're paying attention. All right, so we have a midpoint theorem. And the midpoint theorem says that if M is the midpoint, so here's M, our midpoint, then AM, this length here, is equal to MB, this length here, and that either one of them is equal to 1/2 of the whole thing. Not too bad? Our common segment theorem, okay? RS is this green one, is equal to TU. So what I'm going to do is I'm actually going to draw this over again. Okay, so RS is yellow, and that's congruent to TU, which is also yellow. Now if I add ST to RS, I get RT. If I take RS and I add ST to it, this little middle piece that wasn't highlighted, I get from R to T. And if I add ST to TU, I get SU. So if the 2 pieces that I started with were the same already, and then I add the same piece to both of them in the middle, then the new longer pieces are also the same. Does that make sense? So basically what happens is this part right here, ST, that's what gets added to RS and also to TU. Well, RS and TU were already the same size, so you add the same piece to each of them and you still end up with the same size. That's what that's saying. And it goes the opposite as well. If I start with, if I start with RT, so I've started with RT, and that is the same as TU, I'm just going to use or SU, I'm going to use a slightly different blue. So these two blues are actually the same length. Well, if I take that middle piece away from both of them, then I get RS and TU, which are the same length. So if you start with things that are the same length, and you add and subtract the same size piece from both, they're still the same length. Does that make sense? Right. We're not going to go through the proof. See, oh, there it goes. Pretty, wasn't it? Okay. If DF is the same as EG, so DF is the same as EG. Okay, those two are the same. FG is 16. EF is 4. I want to find DF. Well, if these two make up EG, that makes EG 20. And since EG and DF are the same, then DF is also 20. Does that make sense? Yeah. All right, let's try some of these. We're going to find the length of MQ. MQ goes from here all the way to here. So I have 2 9s, that's 18, and 2 23s, that's 46. So that's 58. 56 plus 8 is 64. Okay. Let me double check myself on that because I'm not 100%. Yes, 64. Okay, LO goes from here to here. So 23 plus 9 plus 23, so that's 46 plus 9, which is 55. So far okay? Alrighty, we want to find WY, so we're looking for this part right here. WX is the same as YZ, and then of course XY is the same as itself, so if I have XZ, that's this big piece over here, is 47, and XY is 32, but I'm trying to find WY. WY is going to be the same as XZ, so WY is just 47. I don't actually have to do any math on that one. If I was looking for WX, I would say 47 minus 32, which would give me the lengths of these little pieces, which would be 15 each. And then find ST. QR is the same as ST. QS, that's this length here, is 2. RS is a half. That makes this 1.5, which makes this 1.5. So ST is equal to 1.5.